Okay, guys, I want to provide you with one more GeoGebra link, which is uh, creating the graphs of the sine, cosine, and tangent by unwrapping the unit circle. So, of course, what we're doing here, we're going to say let's form the sine graph. Okay, so as we move counterclockwise around the unit circle, we follow the height of the y segment, the length of CD, as a function of this angle, and we see it sweeping out, forming the graph of the sine. Okay? Now, when we are at pi over 2 radians, that is, of course, 90 degrees, the y value or the sine is taking on its greatest value. Okay? Then it's going to start declining, all right, until it comes back down to 0 at a half a revolution or pi radians. And taking on its lowest value down here at -1 when we swung around a full 270 or 3 pi over 2 radians, and then back to its starting point, having run through one full period, one full revolution, okay, of 2 pi radians, okay, moving, okay. Now, if we want, we can also look at generating the cosine. Of course, the cosine is going to be concerned with following the value of the x-coordinate of this point in question, which of course is this length here, AD, our length here, AD, which starts out at its greatest value of 1. And as we sweep around the unit circle counterclockwise, and that angle changes, at this point, 0.71, we're going to be approaching pi over 4, okay? So here we are right about at pi over 4. Then when we hit pi over 2 or 90 degrees, we're at 0. Then the cosine dips negative because the x values take on negative values there until it reaches its lowest value here at pi radians of -1. Okay, working itself back up to 0. Okay, and then uh, coming back to its starting point where it started with a value of 1. There's our graph of our cosine. So this applet is really convenient and does explain how the unit circle is used to generate the graphs of the sine, cosine, and as well as the tangent, which of course we'll look at later. So look at that and learn from it. Okay, it's a very valuable tool for you.